Hi everyone, my name is Leah Oxford and I'm the Global Marketing Communications Manager for ABB Energy Industries. And thank you today for stopping by to listen to our session on ocean innovation, powering the seabed for a sustainable energy future. This session is a modified version of the conversation that we had planned to have with the CERAWeek community earlier this year, and to stay connected during these difficult times and share our insights on key thought leadership topics, we have decided to bring you a version of a virtual CERAWeek. We hope you leave a comment on the recording or reach out afterwards to let us know your thoughts on today's conversation. And with that, I will introduce our speakers today. So first we have Martin Grady, who is our Vice President and Global Industry Manager for Oil and Gas. And we also have Asmund Maland, who is the Vice President for Subsea at ABB Energy Industries. So to start our session off, I'd like to take us back to the early stages of the JIP between ABB and its partners. So Martin, what was the main purpose for undertaking such an innovative project? And maybe you can just provide some background information as well.
Yeah, thank you, Leah, and hello everyone. I think the background to the project was a fairly simple one, really, which is that the easy reserves in oil and gas have already been developed. So inevitably, there's a move to look further from shore in terms of offshore production, further from existing facilities into deeper water to find those new areas of reserves. Alongside that, there are small pockets of reserves relatively close to existing facilities that could be exploited if we could find a low enough cost solution to do that. Otherwise, these reserves could become stranded. So having an entire oil and gas facility on the seabed has become a fairly long-term goal. I think it's also elegant from an engineering perspective, but clearly technically very challenging. And the provision of electrical power is one of the most difficult of those challenges. So that's why in 2013, ABB, with our partners Equinor, Chevron and Total, formed a joint industry project, a JIP, to develop a subsea solution for the transmission of electrical power. Asmund, perhaps you would like to comment on why ABB became involved?
Yes, so we were actually engaged in the subsea power business since about the year 2000, and gained more and more experience over the years. And then, say 2007-8, it became apparent that Equinor wanted to build out the so-called Åsgård field with a subsea compression station. However, they needed to qualify an electrical system to power the compressors over kind of a 50-kilometer distance with high power. So we got an R&D contract with Equinor and started to work on the topic over several years. And I think the performance we show there with the trust we created and the solution really worked and so on, and has been a kind of very reliable over the last 3 to 4 years, close to 100% reliability or availability. So that was the foundation for Equinor and the partners to kick off the subsea JIP with ABB.
Martin, from an operational and maybe also a technical standpoint, what did the JIP team hope to achieve by successfully completing this project?
Well, I think the objectives of the JIP were very well defined in terms of the industry challenge that I mentioned earlier on. So the aim was to develop a subsea electrical system that could deliver 100 megawatts, so enough to drive 2 to 3 major platforms over a distance of 600 kilometers. And to give people a feel, that's slightly further than the distance between Scotland and Norway. And to depths of 3,000 meters. Of course, being on the seabed, this needed to be very reliable, so a 30-year operating life was defined. Then thinking of the stranded or potentially stranded reserves I mentioned earlier on, in the schemes appropriate to that, we were looking for 30 to 40% cost savings over current schemes. So that, I think the objectives of the JIP were very well defined in that sense. Asmund, I don't know if you would like to add any more.
Yeah, so the Equinor had this vision of, let's say, the so-called subsea factory, which you put could produce oil and gas without any platform going directly to shore. Obviously the power distribution subsea is immense important to realize such a vision. And of course was also the economic picture where if you have if you're far away and you have multiple consumers like pumps and compressors, you need to have one cable to each, and if the distance is quite far, that becomes very expensive. So that's why we undertook this project, to have just one cable and distribute the power subsea. And of course, there's also a tremendous challenge is to be at 3,000 meter and have a kind of what we call a pressure compensated equipment, which means that we have the same pressure inside and outside the vessel. And the consequence of that is that you really need to qualify each component, the electronics, the semiconductors and so on, to withstand, be placed in oil, and you have to withstand also the high pressure. So this led to a lot of test facilities around in ABB to qualify all these components over time. And that's why this project kind of took 5 years to make sure we achieve the highest possible reliability of such a system.
Martin, I don't know if you had anything to add to that, or?
No, I don't think so. I think, as Asmund says, the initial focus was on electrical components and things as small as capacitors and semiconductors to understand how they behaved under pressures of up to 300 bar. So that's 4 times more than a nuclear submarine is designed for. And then the reliability challenge is very significant, and that required extensive and carefully designed testing. And I think that's where the collaboration within the JIP was particularly important, and that work was mostly carried out in specialist test facilities.
Yeah. When you think about, how the offshore industry has transformed in the past few years, even or more than that, and you see this solution becoming something that would be very attractive to a lot of offshore operators. I know you had mentioned earlier, Martin, the CapEx savings that potentially can come from deploying this subsea solution, which we all know right now is top of mind for a lot of these larger companies. So with this being the key driver, and combined with what's going on in the market related to the energy transition, how do you see the offshore industry continuing to evolve into the future?
Well, I think it's a good question, Leah, and I think firstly we must reflect it's always been a technologically driven industry taking on big challenges, and this subsea electrification challenge we've talked about is just one more example. So I think there's an array of issues that we can tackle through technical solutions. If we focus on the oil and gas part of the offshore industry first, I mean, efficiency is key. It's key to reducing costs, but it's arguably even more important in reducing carbon emissions. Oil and gas production will be here for many years on a large scale, so efficiency improvements can be a major contributor to tackling global warming. Also, more autonomous operations. I mean, the subsea production facility is a great example. Clearly on the seabed, the opportunities for maintenance and intervention are very, very limited. But autonomous operations in general improve performance, reduce costs, and importantly, they take people out of harm's way. I think in due course, we'll look back and wonder why we had people on platforms in the first place. Then there's the whole area of offshore energy generation in general, so beyond oil and gas. And Asmund, perhaps you'd like to comment on that.
Yeah, so obviously the equipment we developed was specified for the oil and gas industry, but it's no secret that a lot of requests to ABB these days goes on. Can we, for example, build a substation subsea, collecting wind power, for example? And obviously this is a very interesting topic, so we are exploring that to see the cost benefits of such a solution. We also see that kind of, as you say, Martin, the offshore energy production. It can be oil and gas, it can be wind power, floating or fixed. In the future, we foreseen they start to generate hydrogen, and maybe even further on subsea mining to get minerals, which there are large reserves, you know. So the question is how to get it to the surface the most efficient way. So as we move forward, we really need to explore these opportunities. And actually, from ABB side, we look at this as a kind of holistic solutions with several, ways of producing energy.
Great. I think that's an excellent way to end today's session. So I appreciate both of your thoughts and insights today. And also thank you to everyone that stopped by to watch this video. We hope to talk to you soon. Thank you.